In this video, we're going to review metric units and scientific notation, and I will introduce you to a new method called dimensional analysis. Now, did you know that we are still one of the 3 countries that uses the English units? The rest of the country, or the rest of the world, uses metric units, right? When we talk about inch, foot, and yard, and mile to talk about length or even distance, other parts of the world is talking about centimeters, meters, kilometers. When we talk about temperature, we say Fahrenheit, while the rest of the world uses Celsius. We use gallon, pint, when the rest of the world uses liters and milliliters. We use pounds, and the rest of the world uses grams and kilograms. And why do we in the US use metric units in our science classes? Because think about how scientists communicate and how we share data. We don't keep the data amongst the scientists just within the US. We are sharing data and we are communicating with all the different scientists and all over the world, right? And so it's important that our units are the same as their units. And so if it's not the same, we have to make sure that we are converting our units so that they are the same with the rest of the world. You guys probably remember this mnemonic device, King Henry died by drinking chocolate milk. It all stands for kilo, hecto, deca, base unit, which is meter, gram, liters, deci, centi, milli. And the way that you use this in elementary or middle school is that depending on the number that you were given, you would just move the decimal over to the right, and you would move the decimal over to the left to make sure that you are converting your units to whatever you are being asked to convert it to, right? Well, we're going to review that very briefly to see if you remember how to move your decimal, but after that, I'm going to teach you how to convert these units using a method called dimensional analysis. Now, the base unit for length is meter. The base unit for weight or mass is gram. The base unit for volume is liters. And the base unit for amount, like amount of atoms, amount of molecules, is mole, which we will talk more about in the next video. Now, in addition to King Henry died by drinking chocolate milk, you do need to know these prefixes as well: giga, mega, micro, nano, and pico. So on the right, you will see that 1 gigameter is equal to 1 times 10 to the 9 meters. And these are, the base unit is meters for this example. 1 nanometer is equal to 1 times 10 to negative 9 meters. 1 picometer is 1 times 10 to negative 12 meters. And make sure that you are also familiar with the abbreviation. So if you see cm, then you know that it's centimeters. If you see pm, then you know it's picometer. If it was liters, then it would be a capital L. If it was grams, then it would be a lowercase g. And if it was moles, then it would be MOL. Go ahead and complete these sentences. How many milligrams are there in 1 gram? There are 1,000 milligrams in 1 gram. How many meters are there in 1 picometer? There are 1 times 10 to negative 12 meters in 1 picometer. There are 10 decimeters in 1 meter, and there are 100 liters in 1 hectometer. Now, we use these so that we are able to convert from one unit to another. We call them conversion factors. We can call them ratios, or we can say that it's a relationship between these 2 units. So let's take a look at these practice problems. And you're going to just go ahead and use the chart below to convert these numbers. So 480 centimeters is equal to how many meters? Remember what you did in elementary or middle school? You're given centimeters and you want meters, so you move the decimal over to the left 2 times. So instead of 480 centimeters, we now have 4.8 meters. What about 75 kiloliters? So we're at kilo, and it wants liter, so 1, 2, 3. we have 75,000 liters. Go ahead and take the time to do numbers 3 through 6. Are these the answers that you got? If you did, great. Now, throw that method out the window. We are not going to convert our numbers and convert our units using this mnemonic device. We, again, are going to use dimensional analysis to convert our units. But before we get there, let's briefly review scientific notation. Now, we use scientific notation to represent very large numbers and very small numbers. We don't want to write 0.0000005 because, first of all, that's way too many zeros. I don't even remember how many zeros I just said, right? And so to represent that, we use scientific notation. So scientific notation has a base number and then a times and then 10 to the power, right? And so if it's a number times 10 to a positive exponent, we know that we're dealing with a very large number. If it's a number times 10 to the negative exponent, then we know that we're dealing with a very small number. Now, if you have a number and you want to make it into proper scientific notation, when you move the decimal to the left, the exponent will be positive. So for example, if you have the diameter of the sun as this number here, what you want to do is you want to start your decimal out here. This number doesn't have a decimal, but you're going to start it out here. And you want to move the decimal over until you have one non-zero number to the left of it. One and only one. Okay, one and only one non-zero number to the left of that. So how many times do we move this decimal over? 6 times, so we rewrite this number as 1.392 times 10 to the 6. How about this one? The diameter of a hydrogen nucleus is already in scientific notation. However, this is not proper scientific notation. Why not? Because proper scientific notation should only have one number to the left of the decimal. How do we make this number into proper scientific notation? Well, you pretend that there's a decimal out here, you move it over to the left 2 times, and so what happens to this exponent here? So we move it over to the left 2 times, so to the exponent we're actually going to add 2, okay, because when you move the decimal to the left, the exponent will be positive, so you add 2. So what is negative 15 plus 2? It is negative 13, so we rewrite the answer as 1.75 times 10 to the negative 13 meters. Now just the opposite, when you move the decimal to the right, the exponent will be negative. So let's take the density of air at sea level. Now, yes, this is not a very small number, but just for the sake of putting this into scientific notation, it has a decimal. We want to move it over until we have one non-zero number to the left of that decimal. So how many times do we move it over? 3 times. So we rewrite this number as 1.2 times 10 to the negative 3. Go ahead and practice converting these numbers to proper scientific notation. Rewrite these numbers in proper scientific notation and round the numbers to 2 significant digits. Play the video when you're ready. These are the numbers you should have gotten. Did you get these numbers? If you did, virtual high five. Now let's go over dimensional analysis. Dimensional analysis is a method that scientists and engineers use to help convert from one unit to another. Now this is just an introduction. We're going to use this to convert our metric units from like kilometer to meter, and then we will continue to use dimensional analysis throughout this entire year. So make sure that you are paying attention right now and that you follow these steps. And remember, you can always come back to this video to replay it. These are the steps for dimensional analysis. Dimensional analysis is also known as the fence. In some other YouTube videos, they call it the T method, but just know that they all mean the same thing. These are the steps that I'll be using in the video. Maybe not to the T, but these are the steps if you need to refer back to it. It is on your notes. All right, let's take a look at our first example here. How many liters are in 2,500 milliliters? Now I know a lot of you can just spit out the answer, and that's great, but that's not the whole point right now. I'm trying to use this, something that you know, with a method that you don't know. So let's go through the steps together. Also, if I say on an assessment, show me the work using the fence, this is what I'm talking about. This is the work that I need to see. So here's how you start. You see the fence here. This is the fence here, the thing that's going up and down and across. So you start in the top left corner with the number that you are given in the problem. So what number are we given? We're given 2,500 milliliters. So that's what I write in the top left corner of my fence. Now the next thing I want to think about is, what is the relationship or what is the conversion factor between liters and milliliters? If you need to refer to your notes, please do. But the conversion factor here is that 1 liter is equal to 1,000 milliliters. And if you said 0.001 liters is equal to 1 milliliter, that's fine too. I just don't really like to use decimals in my head, and so this is the method that I prefer. So this is the relationship between liters and milliliters. We could see this as a fraction, right? And so we could rewrite this as 1 liter over 1,000 milliliters. Again, we're looking at it as a ratio, okay? Or we can write this as 1,000 milliliters to 1 liter, okay? Again, we're not dividing these numbers just yet. We're just simply looking at it as a ratio. So now, back to the fence. Here's what we do next. We take milliliters and we're going to bring it down the fence. So we're just going to copy the unit and the unit only. We're going to ignore 2,500 right now and bring down milliliters to the bottom of your fence. And the other side is going to be liters. And what do you think these two fences will represent? It is actually the conversion factor. So we want to match up the units. So if you take a look at the units, here's liters over milliliter, here's milliliter over liter. Which one will we use here? It's the first one, the one that says liter over milliliter, because I want to make sure that it matches up. Liters on top, milliliters on the bottom. Now with the numbers, all you're going to do is simply copy the numbers. So I write 1 on top because it says 1 liter. So where it says liters, I write 1. And then on the bottom, I'm going to write 1,000. Now, when I write it like this, my milliliters, my like units, will cancel out. And I'm left with liters, which is what my problem is asking for. So now mathematically, how does this work? When you go across, you multiply. When you go anything on the bottom, you divide. So this is how it's written. 2,500 times 1 divided by 1,000. So just to show you that the units will cancel out, this is algebra, basic algebra here, right? So milliliters, liters, milliliters. Same unit on top and bottom. So that's why we cancel it out right here. So we cancel it out in the fence. And then, so it's really 2,500 divided by 1,000. What do we get? We get 2.5 liters. And just keep in mind with all of these problems, even though I don't explicitly say it, we are using significant digits in our final answers. Problem number 2, how many meters are in 8,072 centimeters? Let's start with our starting number. So I write my starting number and then I draw the fence. What's next here? I'm going to bring down centimeters. And remember what this next fence is. It's a conversion factor. So let's think about that conversion factor. What is the relationship between meters and centimeters? We have 1 meter is equal to 100 centimeters. Again, you can rewrite this as a ratio in a fraction form. So 1 meter over 100 or 100 over a meter. So if you take a look at your fence, centimeters is on the bottom, which means on the opposite side will be meters. So which one do we use? We use this one. Because meters on top, centimeters on the bottom, go ahead and copy the numbers. 1 next to meter, 100 next to centimeters. Centimeters cancels out. So this is equal to 80.72 meters. Pause the video now and try to set up number 3 on your own. How many nanometers are in 62 meters? Play the video when you're ready. So here's your setup here. We start with 62 meters. We have our conversion factor here with meters on the bottom, nanometers on top. Our meters will cancel out. And the answer is 6.2 times 10 to the 10 nanometers. If you did not get the 10 to the 10, make sure that in your calculator, make sure that you are using the parentheses around the number that's in your denominator. If you don't, then you could get a different number. So don't forget the parentheses, especially when you're dealing with numbers in scientific notation. So if you didn't get the answer, try it again with the parentheses in your calculator. Go ahead and pause the video again and try number 4. Play the video when you're ready. Now here I am showing you 2 different setups. Both will get you the same answer. This one has to do with 1 hectoliter, with the conversion factor 1 hectoliter is equal to 100 liters. And some of you guys like to use a decimal, so some of you may have written 0.01 hectoliters is equal to 1 liter. Whichever conversion factor you use, doesn't matter, it'll get you the same exact answer, which is 9.2 times 10 to the negative 3 hectoliters. Let's take a look at this density problem. And you might be wondering, why are we using density with this? Well, density, if you think about it, could also be a conversion factor problem. We have a density of 0.863 grams per milliliter. We have a volume of 5.50 milliliters, and it wants the mass. And what's the unit of mass? It's grams. So we're actually not going to use density equals mass over volume. I know there's a formula with it, but I just want to show you that even though we're not using a formula, we will use this method to obtain our final answer, which would be the same as using the density formula. Do you have to know this method to solve for a density problem? Yes, because I could ask you to set up your density problem using the fence, right? So let's get started. So we begin with 5.50 milliliters, and that's what we're going to put in the top left corner of our fence. We don't ever use the density, because if you take a look here, it's grams per milliliter. Well, what does grams per milliliter mean? It means grams, that many grams, over 1 milliliter. Couldn't that be used as a conversion factor? It could, right? So here, if we were to write it as a ratio or a fraction, we have 0.863 grams per milliliter. Could we also write it the other way? Not that I'm saying we're dividing it like this, but again, just looking at it from a ratio, as a ratio form, either one of these would work as a conversion factor or as a ratio. So let's go back to the fence. So we have milliliter, bring that down, milliliter written on the bottom, so what's going to go on the other part of the fence? Well, we're going to write grams, right? Because we can only choose between these two, okay? So which one are we going to use? Well, we need to find the one where grams is on top and milliliters on the bottom. So we're going to be using this one here. So go ahead and copy the numbers, 0.863 on top, 1 on the bottom, and that is equal to 4.75 grams. Now you try to set up number 6. Go ahead and play the video when you're ready. So this is your setup, and your answer should have been 5.33 milliliters. If you have any questions, make sure you ask when I see you in class.